Welcome to True Projects. In this video, we are going to explain about a project titled An Effective Heart Disease Detection and the Severity Level Classification Model using machine learning and hyperparameter optimization methods. The global prominence of cardiovascular disease as a leading cause of mortality underscores the critical imperative of early detection and prediction for improved health outcomes. Within this context, the challenges inherent in employing the machine learning algorithms to forecast the CVD using the clinical dataset, marked by issues like class imbalance and the dimensionality complexity, have come to the forefront. While the project have explored the diverse machine learning technique for the CVD detection and the patient severity assessment, a notable void exists in the integration of the optimization method to elevate the model performance. Our project aims to bridge this gap by introducing an innovative approach encompassing the synthetic minority oversampling technique, a range of machine learning classifiers. Through this concerted effort, we endeavor to construct a highly accurate system adept at scrutinizing the clinical data pertaining to the heart disease, thereby facilitating the detection and the classification of various levels of heart failure. Our innovative initiative revolves around the creation of potent machine learning model designed to discern the early onset of CVD while concurrently categorizing the severity level exhibited by the patient. The key facet of our approach entails the strategic incorporation of the synthetic minority oversampling technique to counterbalance the challenge posed by the skewed data distribution. Harnessing a diverse array of machine learning classifiers further enrich the model's discriminant capacity, all underscored by hyperparameter optimization to fine-tune these classifiers for optimal performance. And by aligning our efforts with the medical practitioners, the envisioned impact of our model lies in its potential to furnish the clinicians with the crucial insight into the patient prevailing the CVD condition. The ultimate aspiration is to not only facilitate the timely intervention but also mitigate the heart disease-induced fatalities through the timely implementation of appropriate therapeutic measures. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this step, we need to import the essential Python packages including NumPy, Pandas, Seaborn, Matplotlib, sklearn, XGBoost, and Flask. And the second one is exploring the dataset. Here we need to dive into the dataset to understand its structure and the contents within it, and load the data using the libraries like Pandas. And the third one is data pre-processing. Prepare the dataset for the analysis by handling the missing value, outlier, and formatting the inconsistencies, employing the techniques such as imputation, normalization, and encoding to ensure the data is suitable for modeling. And the next step is visualization using Seaborn and Matplotlib. Create the visualization using Seaborn and the Matplotlib to gain a deeper understanding of the data distribution, correlation, and the trends. And the next one is feature selection. Identify the most relevant features for the heart disease detection and the severity classification. Utilize the methods like feature importance, scope from ensemble models, the statistical test to select the informative attributes. And the next one is of data splitting into the train and the test. Divide the pre-processed data set into the training and the testing subset. And the next one is building the model. Here various machine learning models are built, and the first one is SVC. Stands for Support Vector Classifier, is a powerful classification algorithm suitable for both the linear and the non-linear data separation. In this project, SVC can effectively capture the complex relationship within the heart disease dataset, potentially leading to the accurate disease detection and the severity classification. And the next one is KNN. It stands for K nearest neighbor, is a proximity-based classification method that classifies the sample based on the nearest neighbor. In this project, it identified the pattern within the heart disease dataset by considering the neighboring instance, aiding in the accurate detection and the severity classification. And the third one is logistic regression. It's a simple yet interpretable algorithm used for binary classification tasks. In this project, Ella can offer the insight into the relationship between the features and the heart disease occurrence, aiding in the early detection and the severity classification. And the next step is SGD. Stochastic gradient descent optimizes the linear classifier through the iterative updates on the individual samples. And this project SGD can efficiently converge to the solution for the heart disease detection and the severity classification, particularly for the large data set. And the next one is extra tree. It is an ensemble learning algorithm that constructs the multiple decision tree with a random feature split. In this project, its randomness can capture the diverse pattern within the heart disease dataset, improving the detection and the severity classification. And the next one is XGBoost. XGBoost stands for Extreme Gradient Boosting, is a robust ensemble technique that combines the weak learners to create a strong classifier. In this project, XGBoost boosting mechanism can capture the intricate relationship in the heart disease dataset, leading to the improved detection and the severity classification. Hyperparameter tuning optimize the model performance. And the next one is hyperband parameter plus smoothie plus extra tree. This composite model combines the hyperband parameter, smooth and extra tree. It optimizes the hyperparameter efficiently, mitigates the class imbalance, and enhance the feature representation. And the next one is random forest. It is an ensemble of decision tree that reduce overfitting and enhance the predictive accuracy. In this project, random forest diversity and aggregation, the prediction contribute to the effective heart disease detection and the severity classification. And the next one is voting classifier. Combine the prediction from the multiple models like of random forest, decision tree, and extra tree by the majority voting. In this project, this ensemble approach leverages the strength of the diverse algorithm, aiming for the robust and accurate heart disease detection and the severity classification. And the next step is user gives the input. Create a Flask web application that allows the user to input the relevant data for the heart disease prediction. And the next step is the given input is pre-processed for prediction. Pre-process the user input data similarly to the training data. Apply the consistent data processing step to ensure the accurate prediction. And the next step is trained model is used for the prediction. Utilize the trained machine learning model to predict the presence of heart disease and classify the severity level based on the input. And the last one is final outcome is displayed. Showcase the prediction outcome to the user via the Flask web interface. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the cat boost info containing of the training of that algorithm, and the static folder containing of the assets, CSS, JavaScript files within it, and the template folder containing of the HTML documents like about, home, index, notebook, result, sign in and sign up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the heart is an py CSV file that contains the dataset within it, and the model file contain of the algorithm information, and it is loaded into the project code at the time of execution and for performing the certain tasks such as making the prediction on the new data, performing the specific operation. And the notebook is an IPYMD file which contains a combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this, it will change the country directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues within it. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see the title of the project and some information about it. I'm clicking on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password that are need to be filled. And then click on the login button. Here it will redirect it to this page containing of some input columns that are need to be filled. I'm entering the column as of age with 40 and the gender with 1 and the chest pain type is of 1 and the resting blood pressure is of 140 and the cholesterol and 289 and the fasting blood pressure is of 0. Resting electrocardiographic result is of 1. Maximum heart rate is of 172 and exercise induced angina is of 0 and the old peak is of 0.0 and the slope is of 2. And then click on the submit button. Here it predicted the result as of you are safe and the probability of having the disease is 0.0%. And then click on the home button. It will redirect it to this file and here we can enter the other details too. I am entering the other details of age 49 and the gender as of female, that's why I'm entering 0. Chest pain type is of 2 and the resting blood pressure is of 160 and the cholesterol in milligrams is 180 and of fasting blood pressure is of 0 and the resting electrocardiographic result is of 1 and the maximum heart rate is of 156 and the exercise induced angina is of 0 and the old peak is of 1.0 and the slope is of 1. And then click on the submit button. Here it redirected to the result page and giving that result as you have chance of having the heart disease and probability of having the disease is of 90%. And finally, the conclusion. The proposed machine learning model effectively predicts the absence or presence of cardiovascular disease and classify the CVD severity level. The model integrates the smoothie extra tree and the hyperband for the data balancing, classification and the hyperparameter optimization. The model outperforms the state-of-art model considering the accuracy, recall, FN score and MCC. The proposed model can help the healthcare specialist predict the heart failure and enhance the patient treatment. We aim to create a general framework based on the machine learning to improve the detection and the severity level classification of the different diseases using the real-time clinical data for the future work.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.